Problem 1. The catapult. Can you intuitively trace the trajectory of the boulder thrown by the catapult below before it lands on the ground? Now, if we knew about the projectile motion, this would have been a piece of cake. But we don't know because we haven't studied projectile motion until now. So we'll use some intuitive arguments to trace the trajectory. What's the projectile motion? The projectile motion is when an object is thrown at an angle, say theta, with respect to the x-axis. Hence, it has two velocity components. If the speed is v, it has an horizontal component of v cos theta. Don't get confused by this. Let's call it vx. This is vy, v sine theta. For those who haven't done trigonometry, just take it that there is a horizontal component of vx and a vertical component of vy. Now suppose an object just has a horizontal component. It is just thrown along the x-axis with speed vx. So what will be the trajectory? It will just trace the horizontal line. Suppose the object just has a vertical component called vy and no vx component, then what will be the trajectory? It will just go up. So if an object has both vx and vy component, what will be the trajectory? The trajectory will be the slanted line at an angle of theta, which is the direction of its velocity v. That's the trajectory. However, in this case, there is a force of gravity which is acting in the vertical direction. If no force was acting, the trajectory was the straight line. No force is acting. So if force of gravity is acting and trying to deaccelerate vy, naturally the trajectory will bend. So this is an intuitive way of getting what will be the trajectory. Now in the catapult situation, this is exactly the same case. However, only difference being the line of sight in which the catapult is thrown is at an angle, say phi, from the x direction. But that doesn't make much of difference. The trajectory, the nature of the trajectory will exactly remain the same. Along the line of sight, it will look like this.